Okay, hello everyone. I welcomes to all in our lecture series on superconductivity. In this lecture series, we are going to discuss these topics. In our last 8 classes, we already discussed this much. In this class, we are going to discuss type 1 and type 2 superconductors and applications of superconductors. These topics are very much essential for B.sc, B.Tech, M.sc, M.Tech and various entrance examinations. Okay, so let us start our last topic, that is your type 1 and type 2 superconductors along with the applications of superconductors. Okay, so these topics already have been discussed. Now we are going to discuss the type 1, type 2 superconductors or differences between type 1, type 2 superconductors. So let us discuss the differentiation between type 1 and type 2. First point, for type 1, it is called soft superconductor, type 2 called hard superconductors. Then come to the third point, it strictly follows the Meissner's effect, not strictly follow the Meissner's effect. First, what is the Meissner effect that we have to recall? Here you can see, suppose a superconductor in the superconducting state at t less than Tc. For that, the magnetic fluxes, all the magnetic fluxes are expelled by the superconductor, this superconductor. Okay, if I'm going to increase this magnetic strength, then at a particular magnetic field, all the fluxes will be enter inside the magnetic flux, and that SC is called as the critical magnetic field. Okay, this is so called the Meissner's effect. So type 1 superconductor strictly follow the Meissner's effect. That means below SC, the superconductor in the superconducting state, pure superconducting state, this is the pure superconducting state, just above it suddenly sharply transit to normal state. But in case of type 2, it is not sharply transit to normal state, slowly transit to normal state from SC1 to SC2. Up to SC1, superconductor in the superconducting state, I am telling about type 2. From SC1 magnetic field to SC2, SC1 means critical magnetic field 1, critical magnetic field 2. In between that, slowly it transits to pure superconducting state to normal state. In between that, it has mixed state. So in between SC1 and SC2, type 2 behaves mixed state. So hence type 2 could not follow the strictly Meissner's effect, but type 1 follow the strictly Meissner's effect. At a particular field, at particular SC, it sudden transit to normal state, but in case of type 2, it is not so. Okay, the critical field, second point you just follow, a critical field value for type 1 is very low, around 0.1 Tesla, but in case of type 2, it is very high. If I'm going to consider SC2, around it is 30 Tesla. Okay, because up to SC2 type 2 behaves somewhat superconductivity, and if we are going to consider SC1, this value also around 5 to 10 Tesla. Okay, okay. Next, fourth point, these materials have narrow technological applications due to very low field strength, but these materials type 2 superconductors have wide technological applications because very high field strength. Here some of the example of type 1: lead, tin, HgAl, etc. Example of type 2: NBSN, niobium and tin, niobium zinc, zirconium, niobium, titanium, etc. Okay, so I saw that this question, differentiation between type 1 type 2 superconductor, in exam it is asked to 3 to 4 mark. Always most of the time you can find this question, so prepare well this question for your next exam. Okay, now the applications of superconductor. Here you can see these are the domains where superconductors are applied: in electronics domain, medical technique domain, power engineering domain, microwave technique domain, traffic engineering. Here you can see in electronics, superconductors used for sensor, supercomputers. In medical, very well known fluid diagnostics and MRI, magnetic resonance imaging. Power engineering is used for generator, uh, motor, transformer, switches, cable, energy storage. Microwave technique, superconductors used as filters, antenna, resonators, active components also. In traffic engineering, you can see it can be used as magnetic transport systems, shifts, engines, magnetic levitation trains. Okay, so these are the applications of superconductor. So here we completed our lecture series with 9 lectures. In future, uh, I planned that I'm going to add these two topics: DC Josephson effect and AC Josephson effect. Okay, thank you so much for watching all the lecture videos for this superconductivity lecture series. Thank you once again. Thank you so much.